from IS department of BNMIT, coordinator of the FTP. So we'll be formally welcoming you for the sessions. Later on, you can proceed with the session, sir.
Sure, please.
Yeah, dear participants, it's our honor and privilege to have Sivaram Sundar sir with us today. So he's a head of engineering at Publicis Sapient Bengaluru urban regions. He's a technocrat with a deep understanding of business, people, and technology. He is an expert in delivering business values and solutions by leveraging the people's strengths, using relevant technologies, and collaborating, influencing across cultural stakeholders in a multi-site international environment. He has worked in the domains such as manufacturing, retail, e-commerce, healthcare, marketing, and loyalty. He has worked with products such as INV Track, Order Track, Everest, FlexPoint, and Plex POS. He is well known and is well aware of the platforms and frameworks such as EENEX, TradeSoft, Maya, BX, TAF, TAPI, CC, Rewards, etc. He's worked with most of the leading companies such as Dell International Service Limited, India, Tesco Stores, Philips, Servertra Technologies, Netcraft, as well as with high code softwares. We have much more companies to be listed. We have got a huge profile of sir. Sir, it's very privileged to have you with us, and hand it over to you, sir.
Thank you. Thanks a lot. It's equally a privilege and an honor to be addressing ACTU and ACTE and this workshop. So thanks for the kind words, sir. And if all's okay, I think we can jump into the session.
Yes, sir. Yes, we can proceed, sir.
Yeah. Okay. If you can just give me a minute, let me share the screen, and then we will start.
Doing so.
Hello, sir.
Can you see the screen, ma'am?
Yeah. Yes, sir.
Yes,
it's visible. You can go ahead, sir.
Okay, thank you. Okay, so it's the okay. So in our session today about big data and Hadoop, it's a 3-day sessions. We will be having the first day of the session today, followed by 2 more sessions tomorrow and day after. So we'll be touching upon the big data and the Hadoop elements. We will work towards understanding the big data, the what's, whys, hows, and more. So before I jump into big data and then like to Hadoop, I wanted to understand also the expectations. I get to understand that there's a broader set of audiences with and I want to ensure that I kind of like touch upon and answer some or all or most or all of your questions, and then like so that you can take back something which is more valuable. So if you can take a minute and quickly talk about the expectations from this, it'll be great before we jump into it. And I'd love to make this a very interactive session, so please feel free. This is just not going to be a monologue for sure, and I would like to see it as much as interactive as possible. So that would be a kind request. If you can feel free to also type in the chat windows. Madam, is the chat window enabled? Might be helpful to enable that so you can share their notes or write their expectations and questions.
Yes, sir. We are facing little issue with the chat window. I have given a microphone enabled option for all the participants, and I request participant to go one by one, not to rush toward the presenter. Okay. Go one by one as per the queries that you get into your minds.
Thank you, Mr. Gavin. So let's take like a few minutes to collate our thoughts or our questions and then our expectations, and then we'll go ahead. Okay, just to set the context, I intend to start with explaining why big data and why Hadoop, and basically why are we doing what we would expect to do in terms of like what does big data mean for us, and what constitutes big data, and if the needs are so how do we translate that dream and the need into reality, and what are the tools and technologies, what is the design and architecture, and where does Hadoop fit in terms of like how do we relate to big data. So that's the kind of sequence which I have in mind, and so I would be looking back. So normally it's good to understand that there are always many questions, especially from students, why are we doing this. And sometimes it's very good to understand how things started up, and why we are jumping into the bandwagon of big data in this case, and why specifically Hadoop and why not any other pieces of software, for example. So this is the kind of structure which I'm planning to have for today, and I'll give a few minutes for any questions and expectations, saying that like this is what we want to hear about, so like or we have done something about big data. I want to clarify, have a different question in terms of this application, in terms of design, whatever comes to mind. Okay. Okay. So let's start, and let's have the chat enabled and then keep coming. So why big data? So big data, and what is it different? I mean, how is it different from normal data? And The need is basically arising from changing times and the changing business needs. So what does it mean? So end of the day, like we are consumers, and the businesses, let it be the kind of like the Amazons or the Flipkarts or like the Tesco's or Walmarts of the world, or it could be the healthcare enterprises, Philips or GE or any such company, any such enterprise needs to kind of deal with the exploding scale of businesses in the changing times. What does it mean? Is that the consumer behaviors have changed, right? From in the past decade or in the decades, which has changed the way we look at running businesses and addressing customer needs. Business and markets have changed and evolved. We have digital business transformation. Businesses are forced to transform themselves. What does it mean? As consumers, like we want instant gratification and we want doorstep deliveries and need choices. So let it be like I'm trying to pick up a mobile phone from Amazon. I need to have be able to choose, and I want it today or tomorrow, and wherever I am. Business and markets, the way the businesses were done, let's say, for example, the Batas of the world versus today's like Jabong or Flipkart or Amazon. So the disruptors like like Facebook, Amazon, Apple, Netflix, and Google kind of like have revamped the whole way we think about commerce and computing. And of course, there are technology advancements which are key drivers. There are change in technologies, devices, so many other things, which forces businesses to rethink. And digital business transformation is about this businesses adopting this change. The focus today is around customer centricity, hyper personalization, and dealing with global scale, and catering to both business to consumers and business to business propositions, right? So these key drivers uh, are the initiators of change, and let's see more like what it means. From a consumer behavior point of view, let me just go back even just one decade back in 2010, and a little further towards 2000, which all of us can relate to. Uh, we used to do need-based purchases, and the spend capacity used to be different, uh, uh, considerably less than what we have today. We are willing to wait. We were very cost and value conscious and didn't have many choices. And most importantly, also the awareness was very low. But now the times have changed. So we need instant gratification. Like the example was what I took about, like let it be, a book, let it be, a coloring set for my kid, or let it be a mobile. I want to have it now and here today. Right. So that's about the instant gratification. Higher spend capacity. I'm able to spend more for different variations, and I'm very value conscious. I would like, as a customer, I want to feel good about like what I'm investing, being paid off, even if it is slightly on the higher side. The choices again is becoming very important. So earlier, when we're dealing with shops or like with personal attendants, we'll be having like one or two brands, and we'd be happy to go with it, whatever the business recommended to me. But now it's like the whole world is at our fingertips. So choices have become mandatory. I want to compare 20 different companies of mobile phones with 50 different models before I choose one. And as a consumer, I'm really very aware, right? So how do these transformations happen? We'll come to that. Like some of the things were related to technology as well. Now, in addition to this behavioral changes, the COVID also had played a larger impact in terms of more buying is happening in online, buy in bulk purchases, opt for contactless behavior and curbside pickups and home deliveries. So these are the behaviors which we want, which means the businesses need to kind of like change to themselves to deal with these behaviors. Now, how do they go about it? How were they running before? They were predominantly local. They were running at a limited scale. They had limited offerings to offer. They had a steady growth, and they were focusing on commodity selling over and above anything else. They work towards targets. Now, the whole fact of or the ways of working for selling itself has changed. Now it's global. It's become large scale. You'd get what you're getting in US in wherever we are today in Bangalore, for example, right? Or it could be in a small town, thanks to the likes of Amazon and Flipkart and other marketplaces which have changed the way the businesses operate, right? So it could be larger scale where where the businesses were bound to small towns and small districts. Now we are looking at at serving hundreds of thousands of customers uh, and not restricted to any geographies per se. And that's a big change from serving a few tens or hundreds to few thousands or tens of thousands of millions of customers. And the offerings, since the customers expect more and then there is more to sell, the offerings have increased. As a business, like I need to provide more choices. Now, as a business also, I'm looking at exponential growth. Gone was the weight of that steady growth versus I want to grow 2x, 3x, 4x, 8x, right? As we expand. And from the focus shifts from commodities to services and experience selling, right? When I go to a showroom, I want to uh, feel that and enjoy the experience of shopping where my needs are met, I'm supported with information, data, and I expect the same thing, and I'm to be treated well as well. So this is predominantly carrying over to either my mobile or my website. Wherever I buy, I expect that experience. Now that's kind of again, COVID here has forced to think the businesses differently and to rethink. It has accelerated it. Now, if businesses anyway were looking at change, thanks to the internet, thanks to the 4G, thanks to the mobile and mobile commerce, and thanks to increased broadband. Now, the whole thing has to be accelerated. Now, up-to-date and transparent communications with customers and partners by providing more information has come into play. Focus need for jet and lean inventories and assortments. Now the businesses have to invest, and COVID has forced to adopt new payment methods and delivery channels. Now everything comes at an investment for a business. So because of the customers are needing X and the businesses need to kind of change their ways of working, and how does this happen is through digital business transformation. And there is a lot of hype, or there is a lot of focus around business transformation today. And these two are the major reasons. Now, earlier, businesses used to change, but then they were more around production centric, focused on optimization of resources, right? They were less focused on customer experience overall. They were built around customer loyalty and around getting repeat customers. Even today, it is there, but then things have changed. There is focus for more. So predominantly B2B and very limited B2C. But now the transformation has changed towards customer centric. What does my customer want? What are the products? What are the choices? What are the experiences? Now, how can I build that kind of experiences? What kind of changes which needs to be done in my systems to bring about that experience? Hello. Am I audible?
Yes, sir. You are very much audible.
Okay, thank you. So just going blind, so please give me any cues if.
Yeah, sure, sir.
Thank you. Okay. So, so the question about for the businesses would be around like, hey, I've already invested on an accounting system. I have an ERP. I'm having my sales. I have my merchandising systems. I have my analytics. I have my reporting systems. So what more should I do? How do I deal with the scale? How do I kind of serve a few hundred, that few thousand orders which are coming via my website and like, if as I expand, it's going to be a few 100,000 orders, and then how do I kind of fulfill those orders? How do I capture this information? How am I going to stock for it? How am I going to account for it? How am I going to deliver it through my partners? So there's a lot of changes that the business transformation entails, and not only from a systems point of view, what it means to my workforce, and it ends up in an increase of everything, increased workforce, increased systems, increased integration and talking between systems. The flows have changed, and so on. So it also focuses to cater to new and floating customers equally along with customer loyalty and retaining the old customers. So the business's thought process have changed. So if I have to expand and I have to look at various different segments of my customers and I have to cater to everybody. And even if they don't like it, so I'm happy as long as like at least I get my customer, a new customer at a conversion. And I'll keep the loyalty and programs and run them separately to convert them to next generation. Frequent customers, and that's also related to the mindset of today's generation, right? To a great extent, it could be quite a debate about like did technology and these changes kind of like influence our students and our younger generation today, or is that the expectations and the changes of the generation today is pushing and fueling the change in technology? So that could be a philosophical debate, but I think it's a good mix of both, wherein technology advancements have created avenues and mechanisms of doing things differently, and that has been widely adopted thanks to the nature of convenience, right? So today's younger generation is happy with any level of convenience given to them, right? So catering to this new generation means like they keep moving from one place to another. Like so, today, wherever they get the best of the experience and best of their needs fulfilled, they go for that. Today, they will be shopping in Amazon. Tomorrow, they want to go to Flipkart, even if for a minute, like if my page doesn't load, right? So, and then there's a lag for 5 seconds. So there is frustration. I say like, okay, this is not working for me. Let me go. My payment not fast enough, then I say like, okay, let me try out somebody else. If I'm not having like 4 or 5 choices and then like less amount of details, then let me choose another business. Let me choose another choice and then try for that. This is where we have reached today, and so even getting one new customer additional is a good thing for the business, even if they're not repeat. So businesses invest on that. Caters to B2B, B2C, and marketplaces. Marketplaces have become the way of working today. The happening things. So direct to consumer, direct to business, and then marketplaces where different sellers like from the nook and corner of the country can come and sell you, things over this common platforms, which means that like I'm dealing from earlier I was dealing with 10, 20 suppliers, but today that has exploded to say that like I'm dealing with 100,000 merchants in my platform. So this is like
Hello, sir. Sir, your audio is not audible. Hello.
Hello. Can you hear me?
Yeah, sir. Now it's audible.
Yeah, it looks like the teams got disconnected. So let me go back.
Okay, fine.
Are you still able to see my screen?
Yeah, it's visible, sir. Still visible. Digital business transformations.
Oh, okay.
Slide is visible.
I'm not sure. Yeah. Okay. I'm not sure like how long I got disconnected for, but I was talking about the focus on business continuity.
Yes, sir. That point only.
Okay. Fair enough. Sure. Thank you. So business continuity and then businesses like today, it's a mix. There are businesses which are thriving thanks to COVID. There are businesses which have gone down under totally and then trying to stay afloat and revive again thanks to COVID. One of the businesses which flourished was retail. And one of the businesses like which really took a great hit was travel and tourism. Right. So now the businesses have to either ways like invest on doing things differently and much faster than earlier, and they had to accelerate their transformation, focusing on keeping the business afloat and as well as opening up new channels of deliveries and new business thought processes and avenues. And they're willing and then have to take more technical spend, and the control spend has gone now. They are more cost conscious and willing to conserve cash and working towards implementing faster turnaround times and at the same time dealing with resource optimizations and renewed focus on data-driven decisions. All of these things, how can this be done? How am I going to deal with scale? How am I going to deal with changes in the consumer demands, markets? How do I handle millions of requests per second? How do I handle those spikes? And I need data for all of these things. So I need to take decisions. I need analytics as a business, and that's where all these changes have reached us towards. So there's a focus towards more and more data. With all these advancements, data is getting created. Now the data needs to be processed, and the data needs also to be converted into manageable, usable decisions. Now we saw the customer uh, behaviors, basically, and the drivers which are changing the businesses. What does it mean to technology and engineering, right? So we'll see that in a minute. But before we jump over there, I want to take a pause over here and take any questions or any thoughts before we move forward. Does it resonate? Looking at happening and what is triggering the changes and how consumers' businesses are being impacted and where data is. We have started talking about data now, but then like in different volumes. Okay. So Gagan, is there a option for people to unmute themselves and talk or chat? I still see the chat option is disabled.
So any queries, participants?
I know it's just after the lunchtime. I wish you could have done something different, but yeah, please excuse.
No, sir, you will get, sir. You will get at the end. No worries. We are here.
No problem.
Yeah.
Even otherwise, like, you feel free to say that like, hey, it's too much of boring stuff. Let's do something different. I'm happy for that as well.
So this is really interesting. So like you all started with the consumer behavior. That was the more focused area while you presenting this particular topic. Why do you think the consumer behavior is only one focus point for data analytics?
Oh, very interesting question. I wanted to set the frame in such a way that, we normally jump into solutions saying that, like, hey, this is what I want and this is what I'm going to do. Here's what the input.
Hello.
We normally like tend to forget, like, what caused the triggers, right? So that's why, like, if you keep on drilling down hole, you will find the consumer behaviors and the thought process plays a very, very significant role in the data creation. So that is where, like, I started with consumer behaviors. So we are talking about big data. So there was a time when we are just talking about data, but now we are talking about big data. So what is big data? We will quantify. We will see down the slides like what it means. We have touched zettabytes. We have become we've entered the zettabytes era. What does it mean? We will see in a minute. But then, why big data? How did this happen? How did big data convert into big data? So if not for the consumer behaviors, this certainly wouldn't have been possible. So if a student in your class like asks like, so why should I do Hadoop and why should I solve this problem of product recommendation?
Yeah.
And this is because you want it. Does that answer your question, sir, Mr. Amarendra?
Yeah, you answer the questions. Yeah, yeah, answer my question. In fact, my thought, like, in fact, this is not only market where the data plays the role, but even you look at the finance, you look at the management decisions where the data is playing the bigger role, right, for management decision making. Or I'm a little knowledge, but still you are the better to, So that
Yes.
will personal behavior is also important. Managerial behavior is also important. That was little, I was thinking why only consumer behavior? If the consumer defining with the all those people consume the data, then fine. I'm okay. Yes, okay, right?
Then, yes. No, it's a very valid question. You're right. So we're talking about. So for example, let me take a step back. So mobiles came, right? So before mobiles, there was internet, and once we started e-commerce, businesses had to change their mindset to adopt e-commerce and then start selling over there.
Correct.
So the data that they were dealing with wasn't like, let's say, in a few megabytes before internet came in. After internet came in, so they had to deal with 10,000 or thousands of users and thousands of orders. Now, this is a management decision, and basically, like, they had to either adopt or perish. So that is where the business and markets, kind of like the slide what I'm currently looking at, where the management decisions were taken over here at this stage. So you need to invest on. So what do I want to do? What's going to be my ROI? What kind of business lines and products should I invest on? So how should I diversify? How am I going to give more offerings? How am I going to deal with my growth? So I need data and decisions as well. So for the first time, when you don't have the data, you will have to go with blind faith or like projections. But the moment the data flows in, after like 3 months of business in e-commerce, you will have enough data to think about for the next 6 months and a year. And so how do I kind of like deal with that decisions? I can take well educated decisions if when I have more data. So that is the kind of context. So the consumer
Yes.
behavior, the need for, so once the consumers understood and started adopting e-commerce and internet, so the business started increasing more and more and became generate. Now mobiles came in 2010, and after was when the mobile era started from an m-commerce point. It was crazy. So what was happening in thousands, now it has started happening in millions and tens of millions. Enabled by broadband, and that's where the other push is coming from. So more data. Now I'm have to deal with not even MBs of data. I'll have to deal with gigabytes and terabytes of data.
Yeah.
So thanks for that wonderful question, sir. So that's why so the business angle is here. So there is a demand. There is a need for businesses all to survive and thrive and adopt the change. and what is the actual change that they have to do, and how it got accelerated by COVID. And these are all the things which are leading to transformation in terms of like generation of the data. Okay. If there are any other questions we can take, otherwise we'll jump into the next section. Okay, so going back a little bit onto the tech, we are having a technical session, so like going back to the tech part of it. So engineering and delivery adoption. Now, how do I make this business as a reality? All these changes meant the data and scale has changed. The number of the hardware and devices have changed. Communication channels and engagement mediums have changed. The engineering methodologies and styles have changed or need a change. The languages and paradigms which we're supposed to use to create a solution has changed. The tools and technologies have changed. The systems and platforms, again, like what I was dealing with, has changed. Continuous improvements in automation was another factor which became a paramount. So it is like, if I have to give a very simple analogy, earlier I used to have a small, party with 4 or 5 people. The way I would cook for this smaller group is going to be different. I could still use the same kind of tools, the raw materials, and the time taken for that. Everything is going to be manageable by 1 or 2 people. I can do it manually. But now if I have to plan for a bigger party with say 30, 40 people, then what would I end up doing? So I'll have to make sure that I have larger vessels, larger tools, more helping hands, and more space, quite a lot of things. And again, if I had to do it for a marriage party, then it's like hundreds of people, then the whole mechanism I am going to create eating, to serve my lunch or cook is going to change. I need totally different set of tools which I don't use day to day at my home, but tools which, and the space, the infrastructure, the raw materials, the cost, the helping hands, everything kind of like goes different and exponential. Now, data and scale, early days, enabling this business needs, the engineering, maybe the software engineering part, had to change because the tools I used to build for limited to small scale data and local systems. I was happy with a hard disk with one single console application to deal with the data which was generated for 1 day's sale, which could be like some less than $100. Easier to run in a 1 GB system, a system with 1 GB RAM with even like 20 GB hard disk. But limited focus to analytics. There was no focus to analytics or consumption patterns. More focus on business transactions and compliance rather than end-to-end journeys. But now, with that changes, the way I have to develop software has changed. I need to deal with large and massive data. I had to think about building decentralized systems. So it's like offshoring or like scraping off the cooking and giving away that to be like for external suppliers to fulfill my demands. Like so, decentralize the kitchen and deal with multiple systems. Have to build centralized warehouses or data lakes now. And analytics and consumption patterns has become more and more important for me to take data-driven decisions. So I had to rethink every new feature which I'm going to build on. I would be looking at towards data-driven decisions. Focus on customer data. So I'll start collecting this information, start analyzing this information. Now, when I'm looking at purchasing, where did the customer come from? Did they directly land into my website, or he came through an advertisement? How long did the customer take to purchase? What was the end-to-end journey? Was it like 5 minutes, 25 minutes? How long they stayed in my website, right? And data as a business enabler has become a key thing. Businesses have adopted. Engineering has also started focusing on data as a business enabler. So This there's a big change in how the data and the scale of data is to be dealt with. Hardware and devices. Similarly, earlier we used to write programs only for laptops or servers or desktops. Are the code what you write will be run on only these kind of systems. There were hardly any choices. Now, programming maybe for industrial automation in PLCs was involved, but now with cloud coming in and infra becoming a scattle, right? That's a different philosophy in itself. Like you kind of spin up instances hardware on the whim when you need 100 servers. Today you are able to do that in less than 5 minutes. And if you don't want those 100 servers, you can bring it down. So that's infra scattle. And you can also automate the whole thing using tools like Terraform. Now, then we know every devices that we are having, like intelligent devices anywhere, now means that I have to start looking at dealing with this information differently. Now, how do I write programs for for a mobile, for cloud, and how do I deal with it, and what do I do? How do I monitor them? How do I bring back the data from these things? Has to be kind of rethought. Similarly, earlier there was internet, and then actually there is explosion of internet. Before those days, like we just had similar local enterprises or smaller networks. But today, we can't imagine a world without internet. We can't imagine a world without Google, if not for anything else. Sorry. And we have smartphones. We have social media. It has changed our lives to crazy levels. We can't live. I mean, our kids can't live today without YouTube and Instagram and Facebook. And we have intelligent devices. So I need whatever I used to kind of build data and software for, which was going to only one or two channels. Today, I started advertising about my products into all these channels, into social media, into I push my information into a smart device, connect the devices and control the devices centrally. So again, all of this leads to data sharing and data collation. Massive data exchange, massive rate of change in terms of data creation, transfer, and exchanges. Engineering methodologies. I'll skip through. I'll just say it's closer to the cooking analogy. So now from the client server, smaller applications, now you had to look at websites which are powering millions of transactions per second, which means that for putting that kind of a website, I need a firepower of those many tens of hundreds of or thousands of servers simultaneously giving you the ability to browse and purchase. And then again in the backend, every other layer from the time I place my order till it reaches my doorstep, it has gone through massive scale. Now I have to build microservices. I can't expect one program running in one box to solve all of these things. So I go into microservices. Now I created micro frontends for managing and then carving out only one particular functionality, mobile applications, and so much more in terms of non-functional requirements. How do I now I have a website which is great, but is that good enough? No, certainly not. I need to make it performant. If not, if my website is taking 1 minute extra to load, I'm going to lose my business. How do I keep my performance high? How do I keep my website alive? How do I deal with failures? So engineering methodologies, the way I write programs, the tools I use for that has changed again. And even the agile processes, right? So earlier it was a waterfall and SDLC kind of a model where I could say that step 1, step 2, step 3, I will first take time for requirements, I'll take time for a design development, and then jump into final stages of delivery. But now everything gets crunched, and then I want to give what is most usable for the business and the consumer, because there is a need for faster time to market. So I have adopted agile, so I have to change my development process as well. So I will give you something which has been I'll give you a starter quickly in 5-10 minutes, then I will give you the second course and so on. So the changes in languages and paradigms, choosing there earlier there were a bunch of languages which were good for almost everything. So C, C++, COBOL, Java, Pascal, and you know .NET. But now today, predominantly object-oriented programming. Now I start with functional programming and interactive programming. Why do I have to do that? Because if I don't, I can't deal with the scale of data which is getting generated. So functional programming, I start looking at functions as data types, and I need to take my processing to where the data is rather than the other way around. Because, like, if I have to move data, imagine moving gigabytes of data across the bandwidth, across the network into a central location just for processing and sending the output back. Now, that can't work, that can't scale. So the emergence of functional programming takes more importance. Reactive programming, similarly, like actor-based programming models are more important. I start adopting them and start using languages like Scala and Kotlin for that. And again, there is more simplification of languages like Golang and Julia, which and even R specifically for dealing with specific needs, large-scale data, large-scale processing, and so on. Tools and technologies, again, similarly, like there was like only a set bunch of tools which were there. Maximum, like, I used to have some RDBMS to store my data. I had some app servers or message queues. But today, you know, I can't live today without real-time eventing and processing. Every notification that comes into your mobile is triggered by a real-time event happening somewhere and within some enterprise system, which has cascaded into and reached your mobile, right? So, and for example, when I place an order, I want to get the updates and right from the every other step that it's going through. Hey, had it has the order been accepted? Has it order been started for fulfillment? Has it been packaged? Has it been delivered to the nearest hub? And has it reached from the hub to the central warehouse, right? And from there, like, has it been shipped across to the next step towards the destination? So all these real-time information that is expected means that I have to program totally differently, and then I end up creating more and more data, right? So and start emitting those events, and then it can't happen without real-time eventing and stream processing. So I need distributed messaging systems. I need API gateways for dealing with microservices at scale. I need content development networks, content distribution networks. I need NoSQL databases, event streaming, quite a lot of new things which keep on changing. Systems and platforms, earlier, like, I used to have but as a few custom frameworks and products, but today it is like hundreds and hundreds of open source libraries and frameworks which are available even within the Hadoop ecosystem in our context. But then, like, when we're talking about transactional services, like, which for me, if I have to build a product or an order service in Java, then Spring Boot is my go-to thing, right? So emergence of scaffolding tools and accelerators, and how can I cut down my time to build these as well? So, for example, if not big data, what would I be doing? If not for Hadoop, what would I do? Means that, like, I'll have to invest like 2 or 3 more months in trying to get the right tools and technologies and start building that infrastructure. But these scaffolding tools and accelerators, I would say even Hadoop is an accelerator of sorts. So it kind of helps my consumption and moving forward at pace, without losing and increase my go-to market. And how do I manage all of these scale? I have to invest in automation. Earlier, like, it was logical and even possible for 1 or 2 people to kind of manage 1 or 2 servers and run the application. But today, with this kind of scales, with where, like, imagine distributing a piece of software which has been written into tens of thousands of servers. How do I kind of push that binaries, push my application into all these servers? It is absolutely not possible without automation. So we invest on automation. CI/CD, DevOps is a mindset, emergence of code as paradigms, like data as code, documentation as code, infra as code. So everything has come to a flavor where without automation, things can't move efficiently or effectively. So this is the kind of reasons. There's a kind of change behind the scenes that has pushed us towards big data. So that's about big data, and we have entered the zettabytes era in 2016, but now we are moving even much more faster. So as consumers, data is helping us build more and deeper connections. It is needed. The more Amazon knows about me, it can give me personalized notifications, it give me personalized offers, and helps me buy more, right? And it also gives me more choices. And as businesses, this data given by the marketplaces to the businesses help them to tap new markets, better serve their existing customers, and reduce non-selling items and invest more on more selling products, for example, monetize, and even that they start sharing their data collected by themselves as businesses with other businesses so that they can build on it. Like, so how many times have you not seen, if you have searched for, let's say, a mobile phone, for the next a week or so, you will have, whichever page you browse through, you will find ads related to what you searched for. How is that magic happening? That's about monetization of the data, where one enterprise is sharing the information that they have collected across the other businesses. And companies which are looking to be relevant today and in the near future need to understand the role of data and what data and how the differentiation of the data in their organization and how the data sphere will evolve. If their companies are not already doing it, they're going to kind of be left out or perish. So zettabytes. I'll take a pause here. We will move a little bit faster from here till the end of the session, but I'll take a pause for any questions before we move forward. Okay, so zettabytes, in other words, is just like one level below the the highest, I would say, quantity of measure in the data scale, and we have touched it as an economy, as a worldwide economy. Today's internet usage has touched zettabyte. So it's 1,000 exabytes or a billion terabytes, and that's kind of the data which is flowing through the internet, through the clouds and the enterprises. So it is the enterprises which are generating and sharing the data, and it's the same thing which is being consumed. So it's all kinds of data. You might be asking, how did this happen? So it is because of your YouTube, it's because of your Spotify, it's because of the Amazons, it's because of Google, for example, right? So there is increased video streaming, increased wireless and mobile traffic, increased broadband speeds. Now we are talking about 5G. Imagine what happens in once 5G comes. Because that there is a capacity and infrastructure allows you to do wonders, there would be more innovations coming in terms of convenience and other offerings. So we will be looking at hundreds or thousands of zettabytes in no time now. An increase in all forms of digital data capture and storage. Today, let's take even our COVID related tests and stuff. So I register online, I share my documents online, and I get to see my certificate downloaded from a central location. So imagine capturing this data for a million, a country of 1 billion users. Aadhaar, for example, right? So Aadhaar captures not only the forms data, it captures video, it captures your voice, it captures your retinal images. So it's basically data in all kinds of forms and source ways are contributing to this explosion. Now, Are we good with this? Like what? So okay, great. So I'm generating so much data. What happens to this data? Obviously, this needs to be stored. Okay. What then if it is stored? After storing, it has to be processed as well. So zettabytes means also petaflops. Means that the kind of like CPU power needed to process that is also a huge differentiator. And now the question is like, how am I going to enable that? How can an enterprise invest in more and more processing power? Do I need a supercomputer, or can I do something with my Pi, or can I do something in practical with my containers and then like virtual servers and hardware, right? So, but this is where we are going to. We have already touched this kind of data, and we're dealing with processing this kind of data. What does it mean? There's a little bit of stats. Very interesting to see that, like, and the big data, what we are talking about is about 7 billion humans using the internet. And Google alone serves 40,000 searches. So imagine the kind of like data power that like, Google needs to invest upon. So every minute, for example, Snapchat users share 500, almost 5.5 lakhs of photographs. What kind of systems are going to handle those things? So we'll see. Maybe are they using Hadoop? Maybe, or they have some other solution. But at the end of the day, I'll not read it out, but you get an idea, like, what's the kind of scale that we are dealing. And this is the scale which we talk about really big data. It's like, I was trying to find a easier to go analogy. And that easier to go analogy was like, hey, we're talking about colleges. We're talking about students. Why can't it be universities? How about, what is big data? Is the data around the college, the number of classes a particular student attends in a particular college, bubbling up. So I might be having 20 different streams, 8 different classes per day, 100 students attending each class. Their attendance data could itself be massive, right? And let's look at like what are the other data that can be related to understand student performance and predict and forecast like what can be done differently for improvising the grades, right? So then I'm dealing with a large quantum of data, literally records which are not in thousands or tens of thousands but in millions. And this is going to be for a particular, let's say, like one academic year. And if I have to deal with more accuracy, then I need more data. So I would need to deal with projections from the last, or data with from the last 10, 15 years. Then it's 10, 15x of data which I should have collected. So that into 10 into so 100, that itself goes into 100 to 150 million data, records of data for a particular college. Now, if that gets into a district level, to a university, and that bubbles up into the state and at the national level, then we're talking about humongous data. And if the ministry has to build a system to deal with the data in real time, then they would be dealing with big data. So similarly, like the university would be doing it at a lesser scale. We are talking about gigabytes, terabytes, petabytes, and exabytes. So big data is nothing but, it's an ocean of information. It's transactional data, search data, device usage information, all of this that needs to be correlated and consolidated. Is it good enough to store it, capture it, and store it? No. I need to consolidate. I need to I have multiple data sets of million records each. Then how do I kind of map and correlate between these two to find out there's another data point or an output? Anywhere, anything digital data gets, which is getting created anywhere and anytime and anything in different forms. That's what we mean to say. Used to derive analytics and drive the decisions, exceeds the capacity of traditional databases. Now questions like, now I'm talking about millions of records, tens of millions of records, hundreds of millions of records, and now I'm going from gigabytes to terabytes. How can I use my MS SQL or MySQL as a traditional RDBMS to deal with it? In simple terms, I just can't. Even if I can, how long is it going to take for me and what kind of resources are needed, and like my systems will just can't take the load, they will break. So big data is the amount of data that exceeds the capacity of traditional tools and systems which they can handle in volume and variety. The scale needs distributed storage and distributed processing. What it means, we will see in a while. Now, if you look at the visual, we are talking about ERPs, which was like smaller businesses, which would generate, let's say we could generate smaller enterprises. It could be a Tally kind of a system. It could be a SAP, which is powering a particular factory. Then we are talking about, generating gigabytes of data. But the same thing, the moment I'm talking to, a customer base with like say 100,000 customers to 1 million customers, then providing data to them, offer details, orders, customer support, sales, service, touch points, support. Now that is like NX of data, which results in terabytes of data. Right? So the CRM systems usually deal with more amount of data than the transactional systems. Now, thanks to the web deals, what is mean to a web-based system is basically we are touching in petabytes across years. Now, what more? Did we think like this ending? No. Now, from mobile, from internet, we move to IoT. That's a part we didn't touch upon at all, but that IoT is another explosion, right? So it's like imagining every other device that you see is able to generate data and communicate and then get controlled. So today I can, from my mobile, I can control my light, and I can control my geyser, and I control my refrigerator. So imagine the tens of thousands, millions and millions of devices which are going to keep on emitting signals and events. Now that is again big data. All the sensors, all the business feeds, all the view analytics of videos, and every song which has been played in Spotify, and sentiment analysis as in terms of like who is buying when at what age groups, and social network. I don't have to talk about it. So this is what exactly is about big data that gets generated out. Tons of use cases across different verticals, businesses, financial services want to have their decisions and analysis around fraud prevention, trading. Ma'am, can we ensure who is not talking is on mute?
Yeah, we have muted a participant, sir.
Sure, thank you. So again, I will not read through the use cases, but we will touch upon some of the use cases. But every other domain, like healthcare, for example, genomic data for medical trials, DNA, assessments or examination, medical research data. There's tons of use cases from healthcare. Off late, if you have seen, the concept of intelligent ICU has become very famous. So that's about like every patient's vitals which are getting managed gets to a central location in terms of continuous monitoring, and then predicting what would happen with this particular patient, like let's say in a day or two, right? What could be anticipated. So similarly, if in retail, for example, we want a 360 view of the customer, CDPs as we call them are becoming very predominant. Customer data platforms, wherein I want to know everything about the customer. I want to build a 360 view of the customer. So we'll see more of it, but there is no dearth of use cases. Every other sector, business has a bunch of use cases for dealing with big data. So the only solution that they can deal with is when they leverage big data. Now, I spoke about CDP, the customer data platforms and marketing technologies. 80% of Google's revenue comes from ads, not from their search, not from their maps, not from their other value-added offerings, but 80% of their revenue comes from their ads. And for anybody to provide or pitch in for relevant ads and needs basically like to understand their customers, so we need to build the dedicated systems. And in an enterprise, what happens is like, every other department would have invested in a different system. They would be capturing customer data in different points of time. So account system will be representing differently. The billing and the registration system would be capturing customer data differently. The customer support departments would be capturing it differently. So it'll be just crazy. And amounts of data, there'll be a lot of duplication, and even identifying customer identification and deduplication and creating a customer profile is one of the most challenging tasks an enterprise faces in today's day. So CDP, customer data platforms, and marketing technologies, MarTech as we call them, need to build customer personas, behavioral profiles, to understand their customers, to ensure that they are dealing with the same customer as they think they are dealing with. So that there's basically integrity and accuracy of the customer. They might have given multiple addresses. They might have given multiple numbers and mail IDs. You need to kind of collate them and try to figure out, hey, Siva in the accounting system versus Sivaram in registration versus Sivaram Sundar in your support, all indicate the same person, even though they are having a couple of different mail IDs and numbers. So, and then like, what did I purchase? What did I do? Target. This is important for me to understand and go for a targeted selling, upselling, or cross-selling. What to sell, when to sell, how to sell. New customer acquisition. How am I going to get new customers? Ads come to help over here big time. Against social media, ads in the social media, in the messenger, in the chat applications, within the mobile applications. That has become a huge market these days, wherein like you create an mobile application, you can opt in for ads, and then like every mobile application has become a channel by itself. So if one application is taken by 1,000,000 customers, and if you are sending your feeds, or like hey, I want to advertise these 10,000 products through your application, then your application has the capability to reach 1,000,000 customers for bringing in that that potential. So how do I identify what information have to be sent to different kinds of applications? So I might be having an education application, I might be having a gaming application. Different, the market segment which I want to target over these two places will be different. So how do I do this? Campaigns. I run campaigns, dedicated period of time for a period of time for promotions and segmentation. Right. Recommendation engines are raised. So in retail, basket analysis, as in terms of like who is adding items to the basket, how long it is staying there before it goes to purchase, or it is going to be abandoned. So that's all about market-based, basket path to purchase, and basket analysis. So similarly, like there's so much more in every other industry. Banking and finance, fraud detection is a major problem for them. Risk management is another one. Healthcare, IntelliICUs I spoke about. Again, patient classification and disease diagnosis is important. Pharma companies internally, they just like makes a huge difference for them to have this kind of data. So in summary, it all boils down to sentiment analysis, customer understanding, fraud detections, risk modeling, modernization of the systems and the data what I'm currently having in my current warehouses by creating more information. Right. So big data in terms, we have already in 2016 we moved towards zettabyte era. In 2025, just hardly 3 years from now or 4 years from now, we are looking at 163 to 175 zettabytes of data being flowing around, which means that if the data has to flow around, it has to be generated, it has to be stored, it has to be processed. And it is going to be unstructured data. 80% of the data is going to be unstructured, which poses even another unique challenge. how am I going to deal with the data, right? So we will look at what makes big data extremely complex and the complexities that comes along with it in a minute. But data is helping us to the businesses to reach new markets, better serving customers, and everything centralized, I mean, revolving around analysis of data. What does it mean? Every business generates the data. It has to collect the data either from its internal sources or external sources. It needs to process the data. It needs to kind of validate the data, and it needs to store the data, and then make the decisions over and above it. So before we jump into the next step, I want to take a pause, and I'm also aware that we just crossed a minute. I mean, we just crossed 1 hour. So if we'll take any questions, and if there is a need for a pause, we can take that. Gagan, madam, do you have any questions? Do we want to have a break? Either is well.
Participants, any queries? Any queries? Or shall we proceed?
Happy to take or just to ease on. I mean, take not necessarily questions, but also thoughts are welcome. Are you able to relate to the need for? I mean, we saw a lot of things, right from what changes have happened, basically with people, with businesses, and how that has kind of induced in creation of data and the flow of data, the technological advancements, and how we need to kind of deal with, how businesses needs to deal with, and then and how we classify and what we classify as big data. And we reached a stage where we'll get into more depth. But is this interesting or boring, or has it been helpful so far? Does it give any perspective? Happy to kind of have any thoughts, dialogues for the next few minutes.
Yes, sir, it's very useful. I hope they'll be preparing the questions.
Awesome. Okay.
To ask you.
Okay, no problems. Okay, because it's also too much of a dump for one session, so I'm just being a little conscious. Okay, now big data as such revolves around 5 V's, wherein if you see, I mean, the first V, it starts from volume to velocity to variety to veracity to value. So volume, if it is the base of the pyramid, value is the top of the pyramid. So value is what business wants to see, and they want to invest on any technology, any means, any tools, because they're going to see some value out of it. So if I'm introducing a new product, if I have a target to meet about doubling or tripling my top line, let's say in a year's time. So what are the right things which I need to do? So I know what my income is, what my earnings are. That how do we wisely invest or grow? So if we see the big data volume as the base, volume of data is increasing exponentially. We saw that, right? So a system or big data is classified by volume, wherein the millions of transactions which are happening per second, which needs to, which we see. Then the same millions of data leads to 10x of internal data. What do I mean by that? So if I'm creating a million products and then publishing in a website to see this, and if I place an order, the moment I place an order, I generate data. So if I just press that add to cart button and I don't do anything, I have generated data. Now there could be 1,000 users who are coming into my website and adding items to either a wish list or my cart, but hardly like 10 or 5 of them would buy. Now what has happened is I had a million product catalog, which is kind of like data which doesn't change very frequently as in terms of minutes or hours. But the moment I'm selling it, the transactional data, I don't have any control. Now that same product got added in 20 different carts in by different customers. So I've generated now 10x more data, 20x more data just from a cart perspective. Now from the cart it goes to checkout, and then it goes to orders, and then all the other systems which are in the link in the chain also have to deal with a X factor of data which is coming in as input. The same data gets to different systems. The order data has to go to the finance, the order data has to go to the order management system, the order data has to go to my partners, and it has to go into my search system, and it'll also go into my data warehouse. We will see that again. So volume is a key pillar. Velocity, the rate at which the data is getting created and consumed. So we qualify gigabytes and megabytes of data per second, which is getting generated or consumed as part of big data. And how is it possible? It's because of the real-time systems and the streaming data, right? So every time something happens in my website, either you're watching Netflix, you're watching YouTube, you're searching for it, something is happening in the background, in the background. So there are systems for which either requests which go for searching, retrieval of data, and the scale of millions of users across the geography, across the globe, result in the velocity. So if, for example, an event is supposed to happen, or like COVID, and we want to prevent, what are the preventive mechanisms and medicines for COVID, if somebody publishes this data as a video, you go in, there are hundreds of thousands of users who would be searching for this COVID information, and you have already generated that amount of velocity of data being consumed. Data is created once, but it is consumed so much. Variety, data in all possible forms and formats. In a normal system or a transactional system, the data is well structured. You have a table design, and you have relations. And that's all structured. You have a spreadsheet. You know what are the columns, and you're not going to change that frequently. The data keeps on growing, but it doesn't. The structure doesn't change. So it's well structured. There is a schema. There is a meaning around it. Now, unstructured and semi-structured data are different forms of data. We will see more about that. Image, audios, video, documents, etc. is all about variety. And you might ask what data is there in an image. So in today's date, if I get an image, I can tell when was this shot, where was this shot, and basically what is the object inside this particular image. There can be a lot of metadata which can be extracted out of different file formats. The resolution, quite a lot. Veracity, which is in terms of quality. So we need quality and accuracy and integrity of data is equally and more important as we let data which is coming in. So there is a sales data which is coming in from from the stores. There's a sales data which is coming from website. The sales data which is coming from mobile. Now, how much of these is cleansed and how much of this is accurate is where the veracity comes in. So, cleansing and removal of any biases, any differences, any inconsistencies, or duplication of data and volatility is another aspect which makes the data useful. and relevant. And value is when business value is derived by processing all of this particular data and generating insights into consumption patterns or predictions or recommendations, which can be actionable, and help to take decisions. At the end of the day, businesses look at top line and bottom line. Increase in that either by increasing sales, increasing profits, or decreasing cost or optimization. That's about it. So big data is all about getting these 5 V's right. So you deal with lesser volume, invest in a big data infrastructure, you're losing money. If you don't have velocity, and if you're just dealing with stale and stagnant data, you don't need a big data infrastructure. Variety is like if you're dealing data in like only one particular format and not in again much scale and stuff, you don't need big data. So all these 5 are important components. Benefits, again, we saw a lot of benefits around. Product and service development. So it helps businesses to analyze the data and come up with like what to do next. It could be based on their customer reviews, cultural trends, and be able to respond quickly. So the product can be shaped, product features can be shaped, services can be customized and made more efficient, thereby generating more revenues and retaining more customers and keeping your customers happy. Predictive maintenance. So any devices like which are basically sold, and the analysis of these either IoT enabled machines basically help in prediction of equipment lifetime and maintenance, and reduce the maintenance cost up to 40%. This also means that I'm getting a washing machine or a fridge, and then if it is intelligent enough and it keeps telling me that it is deteriorating or it's doing good, helps me in my, as a manufacturer, it helps me in planning my inventory of my spare parts and what I could expect for service. I could plan my manpower, I could plan my inventory, I could plan my purchases. So predictive maintenance is a big business. Customer experience, again, it's all about customer. It's all about emotions, and more I make my customer happy, they're good for my business. So personalization and hyper personalization is the trend that um, is this aids growth, is one of the key benefits. Resilience and risk management, um, how to deal with abrupt changes, how to predict failures or issues, or disasters in wait. So big data insights can help anticipate the risk and prepare them for managing that. Cost savings, of course, even just within the processes where there's a large, this purely about increasing efficiency, so which comes to people and processes. And the more information and insights you have about in each and every individual process, how it is being leveraged, helps you optimize it and improve competitiveness, be a better player with their competitors. Okay. Now, we spoke about all the big data, the benefits, the use cases, and so on. So now we have a fair amount of why am I doing this part very clear. Why big data is needed is kind of clear. Now let's look into what is involved and how we are going to make this happen using the right tools. So we dive deeper into understanding the types of data. Now, there are different types of data, just 3 types to be from a high level view: structured data, unstructured data, and semi-structured data. So structured data is all about tables, RDBMSs, well-defined data models, simple to organize and easier to search. So if I take a mobile phone again, like, and I'm looking at a RAM, which is for 4 GB, 6 GB, 8 GB. If I have my attributes called out, if I have a well-defined schema for my mobile, it's a structured data. And if I've represented it accordingly, so it is simple to organize. I know that I have a table for the products, and then what the different product attributes. A RAM could be an attribute with a value. So now it's easily organizable. It's searchable. I can fire a query to pull out all the mobiles which are mapping to that, which have 4 GB RAM and above. It could be financial data. It could be mission logs. It could be demographic details. It could be literally anything which is well defined and kind of can be stored in normally stored in RDBMS or spreadsheet. That's structured data. Unstructured data is about, as it says, it's a dump. In simple terms, it could be a CSV. Even that is to some extent structured data. It could be just like a blob. It could be an archive, a zip file. It could be an image. The unstructured data is easy to store, but then tricky to process. So a social media post, for example. So you can never see what is the kind of comments or like information which is going to be there. You can't separate it out. So at most you can say that it's a comment. It's a type. It's some actions. Audio files. Anybody can upload a file, different type of files, images, open-ended customer comments, for example, or this is data which keeps changing under the same platform and the same product is this cannot be easily captured as structured, right? So in a standard row or a column-based relational databases. So even looking at the volatility of I'm having different types of products, and if I have to, let's say one product having 10 attributes versus one product having 100 attributes, how do I model them? So I can take an example of a mobile phone. There are so many attributes. There's the battery life, there is the weight, there is the dimension, the dimensions, there is the RAM, there is the storage capacity, there is the amount of sensors which are available, the number of cameras and the technical specifications for these cameras, the chipsets, the information, so on. But if I compare that to, for example, a faucet, a faucet has only 4 or 5 attributes. So now how do I use a system and how do I model both this data, right? So this is where unstructured data comes into picture, or semi-structured data comes in help, which could be a hybrid of structured and unstructured data. I could use JSON, for example, and I can have the same product but with 5 attributes captured in a JSON, and also the same another product with 100 attributes captured in JSON, which I cannot do very easily in a RDBMS or in a structured data if I have a schema, because for every product the schema has changed now. So semi-structured data also is around examples would be around emails, wherein you have open-ended data, which is basically the body, but then there are also which can be considered unstructured. There are properties. There's a specific protocol, and then there is a schema which at the metadata. So that's basically a hybrid. So sender, recipient, they're all fixed. Then that's a good example of hybrid data. So devices that uses geotagging, timestamps, semantic tags. Again, there's a combination of structured and unstructured data. So you'll need all of this kind of data which is coming in to analyze and synthesize and get your analysis. So that's where a big data system, a system which is developed to deal with big data, needs to understand structured data, unstructured data, and semi-structured data, and use the right tools to process these. Now, we spoke about data. Where is this coming from? It can come from various sources, transactions. Every day, every moment, things are happening in the business. Somebody is buying, somebody is selling, somebody is asking for a service. So this is all transactional data. There are millions of customer transactions every hour. Device and machine data, for example, IoT devices, machines, which are generated by either like internal or external the devices or like software components. So it could be vehicles, it could be intelligent devices, yeah, which are emitting signals. It could be your POS systems, the cash registers. It could be your delivery supply chain, vans, which are dealing with proof of delivery, proof of pickup, for example, or systems inside your car, which talk about like, hey, I'm running low on fuel, or there are issues around social media. So this is crazy. And social data wouldn't have been in the picture like, at least a few years back, but now we can't imagine a reality without social media. So let it be the WhatsApp chat, let it be the teams that we are talking right now, the posts, the images, and most increasingly videos. So these are the basic systems of the data sources where data originates from. And now we saw data and data sources. Now, what do I do with them? So where do I store? So structured data goes into RDBMSs and ODBMSs. ODBMSs are not used much these days. Very few systems are out there, but there are graph DBs like which are used for managing relationships. RDBMSs for structured data stores. They're good for vertical scaling. What I mean is basically like if you have a huge system with like 64 gigabytes of RAM or 128 gigabytes of RAM and let's say 20 terabytes of hard disk, then it's good for an RDBMS to kind of scale. So that's vertical scaling. If I need to kind of like keep on increasing, I should be able to add more memory within the same infrastructure, then good for RDBMS. There are very few RDBMSs these days which can scale horizontally as well, but it is not it's not a natural fit. It doesn't happen naturally. So this is suited for OLTP, online transaction processing systems, mostly single node based disk based. Object and in-memory databases are better suited for performance, as both storage and processing of unstructured data, and all the processing happens in the RAM. But in-memory databases can't live by themselves. They need to kind of like be depending upon some other systems which should feed them data in and out. And in-memory databases are extremely fast, and you build them, and they also come with the support distributed architectures, and they leverage parallel processing across, and they're highly reliable and highly available. Last but not the least, we have columnar databases, which are very interesting kind of databases where data is stored in columns instead of rows, and it's better suited for analytics and reporting, and good for big data, where like we could use the likes of Postgres SQL, HBase is called still a bridge between NoSQL and columnar database. Yeah. Wherein basically like the needs are write once and read more. So the data doesn't change per minute, per second, per hour. And columnar databases are optimized for faster retrieval of data, basically based on columns, especially good for reporting and analytics. So data where it originates, where it gets stored, and what are the different types of data. Now, there is an amount of this data sources. Now, when we come to big data, the first thing that comes to mind is data warehouse. Now, but there are also terms like, data lakes, data marts, and data swamps. What are these? So, if you look at this, we will see a little bit more into the big data architecture. But here's what it is. Both the data warehouse and data lakes are used for storing the data. So, and each of these big data solutions could be using the tools, any or all of these tools for capturing the data, using these different data formats, and which is coming in from these sources. Now, data warehouses and lakes are fundamentally different in the fact that a data warehouse is built for a specific purpose. It's a centralized thing. We will see more in this. And whereas the data lake stores the data in the raw format. End of the day, what happens is an enterprise collates data from various different sources, puts it into a central place, stores it, and processes it for different purposes, including predominantly for analysis, reporting, and data mining. Right. So data lakes are more of raw data, where data warehouses, I would say, is like more of process data. We will see more about that. Of course, the cost is a different very important factor in choosing whether do you want to develop a data warehouse or a data lake. Now, we saw why, we saw the what. Now, how do we go about building the solutions and building the big data solutions and architectures? What the kind of problems? So, I'm giving you a very high-level, simplified view of the world. I wish the world were like this, but in reality, it's different. So we have the analytics layer. As a business user, I want the analytics, and then at the end of the day, as a business user, I don't care whether you are using big data, you're using Hadoop, you're using SQL, you're using Tableau, or you're using Presto, whatever tools that you're using. I need a front end. I need a portal to interact, which allows me to access the data and provide me the right synthesized information which I need for my analytics. Now that layer is built on the semantics, or basically the data structured data layer, which allows me to slice and dice, pull out, extract the data using my queries, and use that as inputs for my analytics. Now, that semantics layer is dependent upon the data layer, wherein it is this is where the actual data is stored, maybe in the raw form, maybe in the semi-processed form, or fully synthesized, but at a smaller logical context, which is kind of like at a business unit level. So I might have sales data available, or I might have a raw sales data available. So everything comes into the data layer. And so the data, when it gets into the data layer, and either like it comes transformed, or it gets transformed after coming into the data layer before going into the semantics layer. This is the 30K feet of all the variations of all the data architectures you would see, and when it spans out, we'll see it gets into a lot of other complexities. Now, big data architectures involve building the data pipelines. What are the data pipelines? Data pipelines are the glues, or the plug, where it's kind of the scaffolding which brings things together. So we saw about data sources. The data might come from the transactional system, social media, internal systems, or external systems, or partners. That's the data sources. Once the data comes in, it has to be stored, and either this data can come offline in files, batches, whatever, or it could be also real-time messaging, wherein like the notifications that keep coming onto your mobiles, right? That's real-time messaging. So there are the systems or the data sources which emit data in two ways. One is static, the other one is dynamic. One is based on files, the other one is based on messages. So you get this data, it goes into the storage, you process and ingest that messages. Then the data which is coming in from files and periodically goes through a batch processing. The data which is trickling through as and when the events which are happening has to be processed differently. Maybe you can use the same components, but then like the mechanisms are different. You need to invest on a stream processing. So both of these are different ways to process the data. It's coming from two different types of channels, and And then there is a analytical data store, which basically ends up with the process data. And the analytics and the reporting layer is more about the tools and platforms which allow you to query and retrieve the fully processed data and give it back. The orchestration means that, like, not all of these blocks can work in silos, and they have to talk to similar schemas. They need to understand, how the data has to be processed versus stored, because every other block is dependent upon the previous block. So orchestration is key to make sure all these links in the chain is working fine, right? So a big data architecture, what components it will have, and this is one level deeper to say that, this is how a data pipeline, as we call, would look like. Now, data lakes are one of the concrete architecture types. Data warehouses being another, data marts being another one. So these are the three things which we will see. And data lakes as an architectural type is about dealing with getting in raw data. So let's say, like, if I have a file or a bunch of files which are uploaded, it directly comes into the storage. Nothing, no processing happens. Maybe somebody drops a bunch of files. Let us say, like, your pictures. So you're using your mobile, taking a picture, and then it goes to your cloud. That's raw data going into. If I look at Amazon S3 or like your Google, it could be the data lake where it gets to. Just a file gets uploaded to somewhere, and then if you look at Google Photos as an application, it takes the data offline and it processes and it identifies the faces, for example, and it extracts which location, where it was taken, when it was taken, what is the technical details of the product, and then keeps and stores this data. So, and this could happen either pre-processed or on demand. So this is about this is how the data lake works. It's a ELT first mechanism where we extract, load, and transform later. We store large amounts of semi-structured and unstructured data. Click streams are like interesting. It talks about like every other link that you are clicking in your web page and how to make sense out of that to understand your path to purchase. Organized storage patterns for large volumes of highly diverse data from diverse sources. So you can get a data from an SFTP, you can get a data from an USB, you can get the data from a SAP, you can get the data from your auto management system. You can get a dump of data in JSON or just text format or like a EDI data exchange. So you take this data and you'll have a folder structure or like, to say like, all the data which is coming from internal systems, it'll go in a particular hierarchy, in a particular location, all the images, all the videos. It's kind of like, that's what we call as a pattern, right? What works better for us to solve a particular problem. So in this case, like, to organizing becomes very, very important when I'm going to deal with hundreds of large files or thousands of large files. So data lakes are apt for that. They ingest data very quickly. You just like, store the data in the raw form without any changes. So storing the data is the most easiest thing to do in real data lakes. You don't know or you don't want to process it even before like storing it, then data lake is a right choice. And prepare it later, either on demand or like dedicated jobs to post process. This is where like the tools like Hadoop, HDFS, MapReduce come into picture. And data lakes started becoming the happening things around 2000 onwards as a way to store the data. Earlier, it was more about data warehouses. This is good for real-time analytics, and the way the data lake systems are designed and built are for appends and reads. So it's like linearly growing data, more for adding data, like for example logs. So it's like an event sourcing mechanism. You keep on adding to what has happened and in one direction. So it is easier for writes. The writes are faster because less cycles are needed, and reads are even faster because again it's in the same direction. There are no updates, there is no seek, there is no changes. So the cost of this is, more storage and possibly duplicates. But anyways, when disk storage is cheap these days, and so data lakes are not suited for updates. If you are looking at building a real-time system, data lake is not the right choice. So the quantum of data need to be several hundred gigabytes or more to basically um, qualifying for building data lakes. Because you'll need to invest on storage and processing power as well, using commodity hardware. So you can start small and then keep building up. While the data warehouse is more about ETL first. We saw that like ELT for data lake. Data warehouse is about ETL first. You extract the data, you transform it. So this is where the tools like Talend come in, right? So Talend or even Pentaho to some extent has capacity for ETL. So you extract the data, take a file, process the file, apply the logic, and then store it, right? So even before you're storing it, you do that's a subtle difference. So it is also a central data store for entire companies data from all departments and functions. Normally, you take an enterprise like Tesco or like even Flipkart or Amazon, they will have one warehouse throughout the whole enterprise. Data will be flowing from sales, from products, from merchandising, from customer support, from the purchases across all the departments. And the data is well structured. We don't deal with unstructured or semi-structured data in a data warehouse. All the data is readily, consumable with and then processed. Okay, so and then data warehouse is also dependent upon integration, large level to a great extent from every other system needs to talk to the centralized data warehouse. So integration plays a key role with all the systems. Designed for large amounts of data storage for predominantly analytics purposes and reporting, historical and archival data. So I want to fill out the order data from the last 5 years. I should be able to, data warehouse is a wonderful place to be. Archival data is that have regulatory needs and says that I don't want to have more than 5 years of data. I need it, but I don't need it on a day-to-day basis. I will, pull it out on demand and use it. Then, you can store in an archive. But again, data warehouse is a great solution for that. And it is most needed for interactive slicing and dicing of data and analytics. In another way, it can also be seen that as data lakes would be the prerequisites for data warehousing and analytics. While it need not be the case, but it is logical. And data marts are basically subsets of data warehouses focused on a single subject or a line of business. So I just want to have sales information. So after collating all the information, after all processing all the information, the sales related information is separated out and stored, because let's say the sales team could be, like 10 people with, the sales data coming around, like let's say 1 terabyte. But if I'm going to go for support, it's the same. I'll be dealing with let's say like tens or hundreds of terabytes of data, and the data which and the number of people who will be using that would be 100 plus, for example. So it's logical here to separate this data into separate data marts and then seeing them as smaller data warehouses. So data marts are created to serve specific relevant data to select group of users. Now, end of the day, after all the processing across whichever architectures you choose to, we end up in analytics. Analytics is the visual, and then the final leg of data processing, where we have identified the usual informations, evaluated it, and then the systems are able to provide specific answers, right? This could also be run through machine learning and AI as part of the previous processing layers. So it could happen within the analytic systems or before the analytic systems. So data mining is a type of an analogy. Analytic tools like Power BI or like Tableau kind of help us in retrieving this data which is already kept processed. That's interactively. There are microservices and APIs which are built to take this data programmatically as well. Say, for example, if you had gone for a click-through purchase, path of purchase, I would want to see the data related to the path to purchase via dashboards. Then analytics tools play a great role. These analytic tools also, like for example, if I want to use this path of purchase and use the top 3 items which are being purchased, or for a particular customer, what is the frequency of the top 3 purchases, and I would want to take it programmatically, I could do that so with the microservices sitting on top of these data solutions. So analytics is all, and tools are all about ad hoc data retrieval, and that kind of ends up the whole chain of things to say that what, where, when, and how. And now we come to the how part of choosing Hadoop to build and shaping either of the data architectures you are selected. So we will focus on the data lakes, building data lakes, and that's what Hadoop is famous for. And I'll take a pause if there are any questions before I jump into the Hadoop side of things. Okay. Assuming there are no questions, I want to take more time in walking us through over here, but I know that we have only 7 more minutes. This is a logical starting point for Hadoop and our diving deep into the hands-on sessions from tomorrow and day after. So I will touch upon these slides even tomorrow again, just to as a recap. So when we talk about Hadoop, Hadoop is all about, in very simple terms, Hadoop is about bringing together distributed storage at scale and enabling distributed processing and computation on top of it, and making it possible through commodity hardware. So there is history to Hadoop. We will see that. Interesting things about Hadoop is it's open source. Let's say, for example, for a minute, why did Hadoop happen is because of Notch, because of, we're thankful to Yahoo to a great extent. There's been Hadoop started in 2002 as a sub-project of Notch. Notch was a web crawler. They were trying to deal with massive amounts of data and try to kind of create a search engine based on the data which has been harvested. Now, it was not possible with this individual pieces of stuff that they have. So they built out, once they started understanding the scale of it, they realized that I need to run this process. I need multiple machines. Now, I'm going to run multiple jobs on multiple machines. Now, I can't use the same data, so I need to cut the data into pieces and then harvest them. So then to do that, basically, you need certain amount of distributed processing tools and then orchestration and coordination which is needed to say that, say I'm running 5 jobs, but I need to consolidate the output from these jobs as well, and then make sense out of it. How am I going to do that? So that is when the the Hadoop framework was born in terms of saying that, like, you know what, I need the ease of storage. I need a logical layer which tells me that, like, you know, it's like helps me read and write files as if it is a normal file system, but behind the scenes it should be able to kind of deal with scaled out storage. It could be storing anywhere, but I should be able to read it easily. So the challenge without a DFS or a distributed file system here is the moment I take a terabyte file and then split it into smaller chunks and I store it into multiple machines, then I have this big problem of identifying, okay, what part of this data is sitting where and how do I do it? So distributed storage has to be made seamless and easier. And distributed processing is also an interesting concept which we see wherein we take processes to the data rather than taking data to processes. We'll see more of it. I don't want to rush through it. Maybe I'll take a few minutes for the questions and then, like, you know, wind up today's session. And we'll continue with the Hadoop from tomorrow onwards. Is that okay?
Yes, sir. Any questions from participants and? So please get a clarification of any doubts if you have related to the contents covered. The sir will be taking through the answer session from tomorrow.
Okay, do we have any questions right now? It'll be great. And more importantly, I also want to have the expectations. That will really help me kind of, like, you know, focus on specific areas or take up a different style for tomorrow on day of assessments. What is that, like, would help you at, you know, and what is the takeaway from these sessions that will help you a lot in, let's say, for example, addressing your curriculum needs or students' needs?
Okay, so I hope there are no questions from the participants end. Thank you for taking the session, sir. We'll be looking forward for your sessions in the coming days also.
Okay, thank you, Kigan. Before we wind up, then, would this narrative be okay? Because, like, tomorrow, if we have to touch upon the hands-on side of things, would it be feasible for the participants to kind of also practice along with, or, like, would be good for me to walk through sample programs and explain what that would really help? Thoughts around this will
we cannot look into all the participants' progress.
not the progress, but if that is the mode which will kind of adopt, we can certainly do that. Otherwise, like, you know, the way we did it today, I can look into each and every component and architecture of Hadoop and start explaining around it.
Yeah.
So basically, I'm asking, like, you know, what are the expectations around, you know, the Hadoop components of programming, or is it more conceptual, or, like, do you want to help your students solve with specific commands
Like
and
using
things
the
in action?
platform, doing some configurations and settings with respect to platform.
Yeah,
So
more of
be very much useful.
More of commands, more of commands
kind of things.
Yeah. Okay, we will try
Any
to
other
cover.
expectations, or do you especially want to learn from a expert from the industry like this? Be sure if there are any queries from the participation end, and if there are any expectations, if they communicate to us, we will try to get back to you, sir. We will share it with you so that we can have an interactive session tomorrow.
Thank you, Gagan. We'll look forward for the same. Both suggestions and feedback is also welcome.
Sure. We'll look into it.
Thank you all. Thank you
Thank
for
you all.
being a great
Thank you all for
audience.
attending.